Welcome back to The Explainer. Today, we're tackling something pretty mind-bending. We're going to treat the universe not as a bunch of objects floating around in an empty void, but as a computational substrate that absolutely, fundamentally refuses to halt. We're tracing a mathematical blueprint today, going all the way from pure discrete logic up to continuous topological manifolds. It's all about how one incredibly simple rule might actually be the engine generating physical reality. Okay, let's dive into the single philosophical constraint that sets off this whole mathematical cascade. The quote we're starting with really hits the nail on the head. We aren't just saying things shouldn't stop. We're saying that in this foundational framework, a stopped state simply doesn't exist. It's completely off the map.
So, here's our roadmap for today. First, we'll look at the mandate of change, then the origin failure, followed by the size to repair, the emergence of the De Bruijn shift, and finally, the topology of perpetual flow. Let's get right into it.
Starting right off with Part 1, the mandate of change.
All right, so here is the formal definition of Constraint 1, or C1 consistency. The crucial thing to grasp here is that stasis isn't just forbidden by some arbitrary rule. It's literally not a coordinate in the substrate. In a mathematical state space, every single combination of zeros and ones has to have a deterministic destination. If its state maps only back to itself, well, it's stopped executing. It's a dead end. And according to the C1 axiom, dead ends just do not exist in the state space of reality. Everything has to have a distinct legal successor.
Now, this is a really important distinction, the difference between illegally freezing the system and legally preserving a property. A fixed point is exactly what it sounds like, a state mapping to itself, a dead end where the flow completely halts. That's a huge C1 violation. But an invariant? That's totally different. Think of invariants like energy or momentum. The system is still moving, it's still executing, but it preserves a specific quantity while doing so. C1 absolutely forbids the first, but entirely permits the second. In fact, you could say C1 itself is an invariant, the continuous preservation of change.
Which brings us to Part 2, the origin failure. So to actually test this mandate, we apply a linear recurrence over a finite field. Specifically, we're using GF2, which just means we are working strictly in a binary system, ones and zeros, nothing else. We use a linear difference operator as a logical feedback loop, basically adding bits together to generate the very next state. When we run this, it creates an M sequence, or maximal-length sequence. This sequence successfully visits every single non-zero state exactly once before repeating. Sounds like the perfect engine for perpetual change, right? Well, there's a fatal structural bug lurking in the math.
When you look at the math across different lane widths, say n equals 4 all the way up to 7, you hit a wall. In a linear rule with no constant term, 0 plus 0 is always 0. You can't avoid it. Because of that, the all-zero state at the origin maps only to itself, creating an absorbing fixed point. And there it is, an absolute C1 violation. The origin is a state that structurally refuses to change.
So how does the universe handle that? Let's move to Part 3, the size to repair.
The computational substrate literally has to patch this bug so the system doesn't crash and halt. It plays out in 3 specific steps. First, we are mathematically forced to flip the feedback bit of the origin so it maps to a non-zero state. It has to change. But step 2, doing that breaks reversibility or bijectivity. Because we flipped the origin, it now maps to a target state that already has a parent in the sequence. It's a collision. 2 different states are now pointing to the exact same target. So step 3, this legally forces us to make a second flip at a very specific node to fix that collision and restore the balance.
And that brings us to the number 2. Exhaustive computational searches over every possible feedback modification prove that the absolute minimal repair size is exactly 2. You have to flip the origin, and to successfully fix that mapping, you must flip its precise algebraic opposite in the state space. There are 0 free choices here. The mathematical logic completely forces the system's hand.
Let's see what happens when we apply it. In Part 4, emergence of De Bruijn.
It is incredibly elegant how cleanly this specific patch resolves the geometry. The repaired dynamics essentially fold that parasitic zero loop right back into the primary manifold. If you look at the lane widths, our broken 15 cycle at n equals 4 absorbs that fixed point and becomes a perfect 16 cycle, which is exactly 2 to the 4th power. 31 becomes 32. 63 becomes 64. What we get is a single, continuous, uninterrupted orbit of every possible binary state. Mathematically, this is known as the canonical de Bruijn shift. The bug is patched, the system is healed.
The implications here are just massive. Think about uniform transition measure. This idea that no state is privileged over another, and the system spends an equal amount of time everywhere. That isn't just some assumed axiom we decided to plug into physics to make the math work. It is the raw exhaust of fixing the origin bug. The entirety of this algebra is just the explicit resolution of a single collision between the mandate to change and the one mathematical state that refused to.
And finally, Part 5, Topology of Perpetual Flow.
Okay, now we need to zoom out and lift this discrete binary bug fix up into the realm of continuous topological manifolds. This is where the Poincare-Hopf theorem comes in. Because C1 aggressively forbids any fixed points where the flow stops, the transition vector field of reality has to be nowhere vanishing. Mathematically speaking, this forces the universe's Euler characteristic, represented by the Greek letter chi, to equal exactly 0. The Euler characteristic is a topological invariant relating vertices, edges, and faces. But here, it's the bridge. It connects our discrete binary bits to continuous geometric space. The literal topological shape of the universe is strictly dictated by its refusal to halt.
To put that into perspective, let's map out exactly why reality cannot exist as certain basic shapes. A line? It has explicit endpoints. Those are halting points, so it fails C1 right away. What about a sphere? A sphere has an Euler characteristic of 2, which means any continuous flow on it must have at least 2 stationary poles. Think of it like the dead calm eye of a hurricane. The flow has to stop somewhere. C1 aggressively forbids that. So the substrate is forced into shapes with an Euler characteristic of 0, like a torus or a circle, purely to avoid halting.
It is an incredibly profound realization when you really step back and look at it. Physical matter, energy, geometry. They aren't just things inserted into a pre-existing void. They are the geometric consequence of a substrate refusing to freeze. The continuous curvature, the fundamental forces we observe, it's all just the footprint of a system desperately avoiding a fixed point. So I'm going to leave you with this final thought to ponder as we wrap up today's explainer. If everything we call physics, the conservation laws, the topology, the continuous de Bruijn cycles, is really just the universe rigorously executing a no-fixed-point rule, what is the ultimate minimal seed that generates it all? Because if you can define that invariant, you aren't just describing reality anymore, you are generating it. Keep exploring that idea, and thanks for joining me today.